Well, the time has come. So this is the Richmond charity van, and yeah, we tried to balance the cells in this battery previously because it's got a low cell, and it was not successful, and it was acting kind of weird. So it doesn't look like the cell is kind of worn out, and we need to get the battery out and see what's going on, basically. So yeah, firstly, if you're not subscribed, please do so, and a big thank you to my members as well, especially to my gold members. So yeah, I've got this in the workshop. I'm just trying to work out how we're going to get this battery out. Don't do many battery repairs just because I don't have a lift. It tends to be a bit of a pain, but you got to do it occasionally when it's needed. But sometimes it does have me questioning my career choices. But yeah, not actually taken a battery out of a Kangoo before, but it's going to be very similar to a Zoe, basically. So, right, let's go in the workshop and we'll see what's occurring. Right, well, so I've backed it in because the battery on this van is, it's kind of at the back. It's not right at the back, but let's go under and have a look. So, right, I'm just going to get in a good position. Right, so at the back, we've got a spare wheel. And then beyond that, you can actually see the back of it. When I put the camera up, the light gets in the way. So the black box you can see just behind that silver support, that is the battery. And if we come under here, you can see the underneath of it there. So that sort of, is that plasticky cover, I think? So yeah, that's what we got to get out. It's kind of just in front of the rear wheels. Yeah, and it doesn't go forward that far. It's quite compact on these. So just kind of sizing this up, really, working out whether I was going to lift the vehicle up or kind of lift it straight up and leave it there, or lift it up and then kind of roll it forwards, off, sort of away from the battery. But realistically, just looking at that height there, it's fairly tall, and I think that explains why it's not very long. So what we are going to have to do is lift this vehicle up, get my finger out of the camera, far enough that we can drop the battery down. So I've got a couple of lifts and a trolley and all that kind of stuff. Yeah, basically get that battery down and then pull it out the back here, and then we'll see how that goes. So yeah, it's going to be a bit of fun, I think. I did wonder whether to go and do this on some concrete just so that the trolleys and stuff would roll better, but then I don't have the it wouldn't be under cover, and obviously we can't get any damp or moisture in, so I think we're going to go with the sort of more difficult route, but then we can take our time once we've got the battery out and see what's going on. So yeah, I think, and this vehicle obviously it moves under its own power, which is really useful. What we need to do firstly is just have a look at the data so we know what the car thinks is going on, and then we can compare that to what's actually happening inside the battery. And then we'll back it onto my little ramps just to help it get up a little bit, and then we'll start lifting it up. What I have done in the past is use some little lifts, but I don't know if this is going to be too heavy. One moment, please. Yeah, this is a motorbike lift. So I used to do quite a few battery repairs on small electric cars, Mitsubishi IMEVs, which are also sold as a Citroen C0 and a Peugeot Ion. I fixed loads of those, done loads of battery repairs. And they're quite light vehicles, only about 1,200 kilos, something like that, with a battery and everything. They're a little Japanese Mitsubishi thing. And basically, I used to put one of these motorbike lifts under each wheel. These can take 450 kilos, and then literally just like wind it up and just lift the car up, and it was brilliant. So I'd lift it up, get all the battery kind of like disconnected and everything, obviously under trays and everything, and get my trolleys in place and everything, and then you could just lower the car onto the trolley, or lower the battery onto the trolley by lowering the car, or you can leave the car where it is and then lower the battery. You know, you just got quite a few options with those, but these Kangoos are a lot heavier, and I don't think those lifts are going to like it. So I think it's going to be a case of getting the car high enough, getting the battery down, and then that's the point whether you know whether the vehicle is definitely high enough. So I'm going to need to put it on my good trolley the downside of trolleys is the better they roll, the bigger wheels they've got, basically, or I should say the bigger wheels they've got, the better they roll, especially on uneven surfaces. This is quite well compacted, but it's obviously not flat concrete. So, but it's what we got, so that's fine. So the trolley is going to be reasonably high, probably about 5 inches-ish. So the battery's already there. Then the battery has got its own height, and that has obviously got to clear the vehicle. We also got to obviously get it up high enough that we can actually get the battery unbolted and everything. So this has got to go a reasonable height in this van. So yeah, okay. I might do something like breeze blocks under the wheels, because I've done that before and it works pretty well. Because the vehicle can't really fall over if you've got, you know, breeze blocks under all the wheels, as long as you don't go stupid high. And obviously you can put jacks and stuff as well under it, just to axle stands, just to secure it. But yeah, they don't tend to roll away or fall over if they're on their wheels, even if those wheels are slightly lifted up. So yeah, we're gonna see how this goes. And yeah, I've left myself a reasonable amount of space. It's difficult to capture it on the camera because I'm standing in it, but basically there. So I'm planning on pulling the battery out. I may need to twist it round as well and pull it one way, but yeah, I'm hoping to have a battery sat there, and then we'll see how it goes. But yeah, I'm obviously not massively set up for battery repairs, because I don't have a lift, but sometimes you end up doing it. This does drive this. I did wonder whether just sort of take it to a garage a few miles away, but it doesn't have an MOT, so that's obviously not massively ideal. I don't want to get in trouble or anything, so I think we're going to give it a go, and then if we have any major issues I can get it moved down the road. So yeah, well, got to be in it to win it, so let's give it a crack. I'm going to get set up. Alright. Wow, they're surprisingly tall, these Kangoos. Well, when they're on a couple of blocks there anyway. So yeah, I'm hoping this is going to be high enough. So it's on a couple of blocks there. Got some supports at the sides. Got my motorbike lifts there, so I was just using that to sort of support it while I lifted it up. A couple of blocks at the front, axle stands at the front, and yeah, now we can properly see the battery. There it is. So I was just looking at the procedure, and basically I can probably take that one out now, just using that as just supplementary while I move the blocks. Yeah, what we need to do, basically, take this under tray off, then there's some cables to unclip. You can see we've got comms cables in there. So on the earlier Kangoo, the 22, it only had one comms connector, but the 33 has got the two. We can see on here this is 36.4 kilowatt hours total, 33 kilowatt hours usable. Yeah, so we've got to unclip some of this cabling and things like that. I think there's something on the, is it on that side or the other side? I think there's one under here that needs unclipping, something like that. But anyway, we are going to start following the procedure, basically. Obviously disconnecting the main cable, which is on the other side, I think, in that way around. Yeah, and we will see what happens. So I'm hoping this is enough height. There's a reasonable amount there, so yeah, that should be all right. And then basically probably going to turn it around and push it backwards. But we will see how that goes. So yeah, we're undercover, so we can kind of take our time, really. And yeah, sometimes people say, oh, you need a lift, you know, and then you'll be doing it properly and all that. I mean, well, I don't really do that many battery jobs, and it's only the ones other people don't want to do. So yeah, much as I would love to have a lift and it would make it quicker, I don't, you know, I don't do a lot of these jobs, and the last thing I want is the overheads of a workshop, really. So, and especially with jobs like this, we don't know what we're going to find. So garages sometimes say to me, oh, I could do that, but you know, how long is it going to take? What exactly am I going to need to do? You know, I don't want it stuck on the lift, blocking a ramp, that kind of thing. Well, we don't know. We might find that it's got, you know, an issue with one of the modules or one of the circuit boards, and we have to find another module. How long is that going to take? I don't know. You know, but that's fine with me. That works. You know, customer's happy we take this out and have a look. I'm happy to put the time into it, and yeah, let's do it. It's just the low fuss way of doing it, isn't it, basically? So yeah, I'm hoping these are not going to get in the way, but that's just quite good stability, really, especially when we're pushing the battery around. So fortunately the battery, yeah, it starts here, so we are just behind where the front door passenger door ends there, back of that. and then it's in front of the rear suspension, so about that far in front of the rear wheel. So it's just literally that section. Yeah, which is kind of cool. I presume that's where the fuel tank goes, and that it actually sits down a little bit further than the fuel tank, and that's how they fitted it in. But kind of cool, really. So there we go. Yeah, pretty cool. I was always quite tempted with one of these to get one and then get another battery and stick it in the back. Just basically put in some kind of switch box so I can switch between them. But yeah, project for another time. Anyway, right, I'm going to start following the procedure. So it's that under tray first, and then we'll see where it goes. So when it comes to getting the battery down, one way is to get my big trolley here and then a couple of these lifts, and then you sort of wedge them up under it once you've kind of got all the bolts, like, you know, half a turn kind of thing, so that they're easy, you know, easily come out. Trolley there, lifts on it, and then yeah, get the lifts right wedged underneath it, so it's literally pushing up on it, and then undo all the bolts, and then obviously move the lifts down. That's one way. Another way I've done it, where the height was a little bit tight, is actually use the lifts to lift up the trolley. So the trolley is up here with all its wheels, and then you've got a couple of lifts underneath. A little bit more difficult because like the wheels get in the way and things, but that's what you kind of do if you're tight on height, basically. But I'm hoping this is going to be okay. But yeah, we'll see. First Kangoo battery out. Cool, right, catch you in a bit. Okay, so all the covers that need to come off are off, cables are off and out of the way, and I'm just starting to loosen the bolts, basically. So we're at the back, so you can see there's two there, and I'll give you a spin round so you can see what we've got. One thing I need to do is cover the main connector, which I'm going to do in a second. Oh, it's glamorous, this game, isn't it? So, yeah, then we've got one there up by the battery isolator. There's one there. Where are you? There. Then there's a few around here. So that was just for a cover. Ah, there's one in the middle on this side, which is quite bizarre. Yeah, there. So this is on the front. There's just one in the middle, which is kind of odd. Right. And if we whiz around, oh. So yep, we got one there. So this is like the opposite side to where the battery connector is. This is the comm side. One there and one there as well. So that is basically it. So I've given them all half a turn. So yeah, these are the ones you saw from the the first ones you saw, basically on top of this bit of rear frame. I know this is not a great angle, but yeah, obviously literally I'm directly underneath the battery, so it is what it is. Yeah, so I'm just going to put something over that just to make sure that stays dry. That actually looks a tiny bit, is that damp? Oh no, it's a kind of like a grease. It's not, sorry, I was just looking right on here, there's something there, but it was more like a almost a sealant. Odd place for it, but it's not damp though. It's not dampness, it doesn't feel like water. Interesting. Yeah, interesting, obviously, because if there was moisture in the battery, but there's not that kind of fault, so it probably will be in a minute, we'll see. So yeah, this is almost ready to come out. I'm just gonna get my trolley, cover that up, get my trolley, and then we'll just sort of size this up. It's kind of coming to the end of the day, so this is not something obviously you want to rush. So yeah, okay, right, let's grab the trolley and see where we are. Okay, so yeah, that's my trolley sitting there, and that's actually a good size for that battery. Oh, we're getting lots of oh, the light has come on, got permanent flash, so it's shining on the dust. Yeah, so you can see the trolley there. The challenge basically is this bit of frame. I can just go around the other side and show you. So yeah, it's a lot easier from here. So the battery is there. We're going to get that onto that trolley, but it's got to go under that gap, you see, obviously between the trolley and that. So yeah, I think that will go, but we can always lift the back of the vehicle up a little bit more. That's not an issue. So I think what I'm going to do, I'm just wondering whether to do the lifts on the trolley or the lifts under the trolley. I think I'm going to do them under the trolley, because otherwise, if you put them on the trolley, and obviously you've got a lift up, you know, there, it gets to the point where it just pushes on the battery, then you undo the battery and then you lower them both down, so the battery comes down, but then you've got the lifts between the battery and the trolley. So then you've got to use something else when it's down here to just lift the battery up a little bit to slide the lifts out, which is a bit of a pain in the backside. Whereas if you put the lifts under the trolley, and I kind of bought this trolley partly because the lifts fit under it, you lift up the whole trolley, get it right on the battery, undo all the bolts, lower it down, trolley with the battery, and then obviously you just slide the lifts out and happy days. I think I'm going to do it that way. Okay, right, get my lifts and we'll size this up. Okay, I have a plan. So what I'm going to do is I'm going to do it this way. So I'm going to wind those trolleys up until they're, you know, nicely squidged into the battery, and then I'm going to loosen the battery and bring them down. So my battery's going to be quite high because the trolley is going to be up there on the trolley. But what I've done before is basically just get like a bit of 2x4, something like that, put it down the side so the battery falls onto that, this trolley becomes loose, and then you basically put the trolley on the floor, use it to lift up the battery. So we've got like this bracket here, so put the trolley under that bracket, lift the battery a little bit, take out a 2x4, put it back down. So kind of a couple of stages, but it means you don't have to put that lift, you know, right down there, right on its sort of like full extension, if it even goes up that high kind of thing. So it's just slightly safer kind of stage way of doing it. And yeah, and then we'll see if I can actually move the battery on this gravelly surface. Well, we shall see. Right, see how this goes. Okay, so as you can see, we are getting somewhere. So the way I do these is I take them a little bit of the way down, and then you just do a little visual inspection all the way around, make sure you haven't missed an earth strap or a bolt or something. You don't want to obviously stretch or bend any wires or anything like that. So that was all good. Yeah, so that's looking fine. Then went a little bit further down. So now I'm just going to sort out my little little swap around just to get those lifts out, so that we've just got that battery sitting on that trolley. And what I can do actually now is measure to the top. Does stick up a little bit up there, there's a little lump up there, so just to make sure whether it'll clear that metal bar. But then if not, we'll just lift the van up a little bit more. So yeah, just because of because I'm not massively set up for battery repairs, it does take me a bit longer to do these, but I just don't want the infrastructure for workshop, like I was saying, you know. I kind of I do a few battery repairs. Did a lot on those Mievs where I knew exactly what the issue was, and basically on a sunny day on some concrete, I could take the battery out and put it back in again. But those cars are so light that was really viable. But yeah, I'm not really a battery specialist, but I just kind of do it when needed, really. So yeah, anyway, I'm going to get that down, and then we'll be able to pull it out. When I say be able to pull it out, then I'll start trying to pull it this way. So yeah, I'm hoping it's also going to clear these bits of suspension there, rather than having to rotate the battery, although that may actually make it easier. Just pull one side and rotate and then pull it through here. But yeah, we'll kind of see how that goes. Might have to get some muscles to help just to pull this along, but yeah, it'll be all good. I mean, if necessary, I can do something slightly different, but we'll see how that goes. We'll see how it goes. But yeah, it's all good. It's all come down absolutely fine. There's these rather impressive pointy things. So it's not uncommon they use this kind of locating plug that I put on here. So there's one on each side. It's like metal pin. The other one on the other side is literally a whole pin. Yeah, and it sits. If I can get it the right way around, it's got a particular notch it goes into. Hang on. Flanged on one side. There we go. Yeah. So it sits in there, and then in the factory, when they install the battery, it just makes it locate exactly in the right place, basically. So it's just manufacturing assistance, but obviously that will help ours as well, because once that goes in, we know the bolts are going to line up, basically. So yeah, it's all good. But yeah, we can have a good look at the beast, and yeah, we can crack on. I've been pulling out all the diagrams of inside the battery and how to take out modules and things like that. So the early batteries, the 22 kilowatt hour ones, had so if you imagine this, let's just imagine this mats the battery. They had like a front module, a big long run, and they were all stood up like this in a big run, a bit like if you've seen inside a Prius battery. Those modules all stand up. So let's just get some modules. So yeah, if you had a load of those, each, all in a line, and then a one here as well. That's how the 22s were made, 2 massive modules. Whereas looking at the diagram for these seem to be like a stack of cells and then into a module. So that should make it easier, because on the diagram they're showing taking one module out. So yeah, I need to obviously work out exactly which module's got mine in it. There's also a fuse that cuts the battery in half, just to obviously make it safer, basically, because the safety cutout is just like an output cutout on these. You've still got 96 cells in series, so we've got high voltage. Yeah, I've got my gloves and all that kind of stuff, so yeah, but we're just going to take our time with this, basically. I've got other jobs lined up behind this, but I've set all the expectations with all the customers that that's how long it's going to take to fix. If you want to take it somewhere else, that's absolutely fine, but they're happy that, you know, they're waiting for me to do it, and I do it how I do it, and that is fine. So it is all good. I've obviously, I don't think I've mentioned, but I've obviously done high voltage shutdown and 12 volt shutdown and all that kind of high voltage isolation, all that kind of stuff on this vehicle. This is not an instructional video, okay? I'm not showing you how to do it. I have missed steps like the high voltage shutdown because I'm not here. This is not a training video. This is just showing, you know, here's an interesting fault. It can be repaired, and that is that. It is just an FYI video. This is not instructional. So do not try this at home unless you are suitably trained and equipped. He says with some blocks and some gravel. It's all good. Right, I will catch you in a bit. Cheers. Hey, well, it is on the trolley. So there was a little bit of faffing around because these brackets, so as I brought it down, I sort of did what I explained really. I brought it down on my little lifts, and then had some stacks of wood. So the battery then rested on the wood, then moved the lift to here. So these brackets are not, they're not flat, especially this one. See, it's got that nasty kind of kink in it. So I kind of had a bit of wood, and then I was like, well, I don't want to put too much load on here. So, you know, I kind of just sorted out some wood so that it just fitted just under the bracket, just to make sure nothing's going to be damaged, basically. But it is down, and it is slightly too tall for where we've got the van. Because if we go here, so yeah, I want to bring it past that bar, you see, and it's just over it. So there's like, you can see that hatch, that panel that's bolted on. That's got the emergency rescue access point in it. So all batteries have like a point where a fireman can put a hose in it if necessary. So, you know, if the vehicle's been in an accident or something like that. And then there's a corresponding thing there as well if it wants to focus. There we go. So if necessary, the fire brigade can go under the floor. I mean, this is a van, so it probably have like a ply floor or whatever. So you might have a bit of fun and games, but one way or another can get to that hole, pull the bung, and then do the corresponding bung on the battery, and then fill it with water if they need to, basically. So that's what that is. So we need to lift the van up a little bit. That's fine. That was kind of expected. So yeah, I'll just get my little hydraulic jacks and move it upwards. It's not a lot, is it? What are we talking? Is it an inch? Maybe a little bit more. Yeah, sort of about one paving slab's worth. That's by my reckoning. So yeah, let's go with that. All right, cool. So I'm just gonna lift it up, and then see if we can pull it backwards. See if this was a good idea or not. All right, cool. Catch you in a mo. Well, I do declare it is most definitely cup of tea time. My word, it is actually lunchtime as well. So that's that point. It's actually not. There's not a plug, is there? Maybe that's just the point where they can cut through it. Maybe. I don't know. Fascinating. They're obviously not going to undo all those screws in the emergency, and there's only a little plug above. Yeah, there you go. Okay, maybe they've got away, or they've got some clips on here and it blasts it out. Oh, there is a little vent. That's a. Oh, sorry. If I put the camera so you can see it, that is an air vent. But yeah, fascinating. Can't just be doing it through there, can they? Surely. Anyway, yeah, that was actually surprisingly easy, to be honest. It was the bit I was really not looking forward to, was pulling the battery out. So obviously had the battery on the trolley. It wasn't quite high enough, so I've just got some additional hydraulic jacks there and brought it up. So then the wheels, see the wheels are unsprung, so you lift up the body, the wheels don't come up as quickly, but they came up, put some additional stuff under them, and then just lowered it down a little bit, so it's on the wheels and on the jacks. So I'm, you know, this van is on 8 points of contact now. I've got 2 axle stands at the front, you can see, blocks under the front wheels, blocks under the rear wheels, and there's 2 hydraulic jacks there, and that's not going anywhere. To be fair, it can't go up much, otherwise we'll be lifting up the workshop. But yeah, it was plenty enough to clear the to clear that battery with the hump and everything. and yeah, it's a lot easier to pull it when it's this way round. Basically, the trolley's got cut handles as well, so I had one of the handles at the back and one was at the left, so I just pulled the left side round, went round there, pushed it in and just pulled that back, and that was it wasn't very glamorous, but yeah, it's all good. So yeah, I'm basically gonna go and have a cup of tea and some lunch, and then we'll take this lid off. So what we're expecting to see is they're still in the front and back basically, but they're in modules that are stacked up. I have got a diagram showing which module numbers are. I think it's about somewhere under that sticker from memory, but I'll just need to make sure I've orientated my head correctly with that. But yeah, we should be able to take out an individual module and find the one that's got what looks like a low cell, check if it is actually low or if the van is misreading it, if there's corrosion. We just don't know. Maybe this has not been properly sealed from when it was repaired by Renault, we just don't know, but something's going on inside here. I'm just slightly hoping that we don't have to get another battery, because obviously if we have to get this one out of the way and get another battery, well, I've got to get the other battery to under there. I guess I would push it from the front, I don't know. Anyway, positivity. We're going to fix this battery, which I'm fairly confident and hopeful we will be able to do. Right, yeah, cool. I'll catch you in a bit. That was quite cool. I'm just pleasantly surprised how easily that rolled, actually. Yeah, I ended up with a battery from a Zoe ZE33. So 52 kilowatts, more capacity, although obviously technology moves on over time, so more capacity doesn't necessarily mean more weight. The Zoe does have battery heating and battery cooling, although the cooling is done externally. It's got like a cooler unit above the back. The battery is more rectangular, that way bigger. But yeah, sticks further forward and backwards, but has cooling, but it's got like holes in the battery and a cooler unit above it. But yeah, has heating inside, but it's got the same number of cells. But I don't think this is as heavy, or at least it's so much easier to move because it's a smaller footprint and it just fits on the trolley basically, whereas the Zoe one I had was an absolute nightmare to move basically. We had to sort of lift one end and shove it kind of thing. It's just an absolute nightmare. But yeah, possibly just because it fits nicely on this trolley. Trolley's nice and rubberized, so it doesn't move. But anyway, whatever, I will go and have some lunch. And then, yeah, we'll see how deep the rabbit hole goes. All right, cool. Catch you later. Okay, sit rep. I have had my cup of tea and some very nice leftover sausage casserole with chorizo in it, which is something we recently discovered. So that was good. Right, anyway, yeah, so just planning this out really. I think I'm going to swing the battery back round because I've got kind of lots of space here and not a lot there. Just so we can get all the way around easily. We're going to need to undo the lid and lift it off. I think in the instructions, that's the bit where it says this is a two-person operation or something like that, but they usually say ridiculous things like that, but it's all good. So yeah, swing it round, take the lid off, and then the next thing is to try and confirm, well actually the next thing is to take the fuse out that splits the pack in half, because that takes it down to sort of 175 volts, which is dangerous, but if something goes wrong you have more of a chance of surviving, whereas with 350, 375 volts DC you have a less chance of surviving. I mean, ideally we take out a few links between the modules and just reduce it down, but I don't know the exact configuration of the buzz bars, but that's the ideal thing to do with a big high voltage battery like that. In my mind anyway, this is the way I do it, and this is the way I've always done it, is to, if you can remove enough links between modules, then they just become like 30, 40, 50 volt modules, which is low voltage, and then it's safe. Then you do whatever you like. Well, you don't want to drop a spanner in there because it still might blow up, but you know, you've not got that high voltage source that's kind of trying to get to you all the time. Whereas the sort of dealer method of doing it is completely the other way around. What they do is they put so much PPE on, they look like astronauts, and then they have every possible tool under the sun, insulated magnetic sockets and everything, and then they get like a warehouse and stand right in the middle of it with like a barrier around everything, and then they only do the bit that they're interested in. So they, you know, it just seems a bit of a weird way of doing it to me. I just kind of like de-risk it, and then do it normally rather than touch it as little as possible but leave it more dangerous. Yeah, okay, seems weird, but anyway, but yeah, obviously don't try this at home. Yeah, so cool. I'm gonna spin it around, get the lid off, fuse out, and then we'll go from there. All right, cool. Well, I'm quite enjoying this. To be honest, it makes a difference from taking a Zoe apart. And I don't do a lot of battery repair, so this is quite cool. So yeah, this is the later configuration. So as I was saying earlier, with the leaf, you got 2 stacks like that. So like where those ridges are, if you imagine they were cells, the leaf version of the early battery of this one, the one with the leaf cells, and so they're all stood up like that in one stack and one stack. Whereas this one is the sort of separate module type. So yeah, let's just turn that on. So you can see the actual individual cells there, and then that's in a module. I mean, I've probably slightly lied to you, because quite often with Renault you have like 2 cells within each, so they're like in pairs, but you see what I mean, like an individual, you know, an individual unit of batteryness, and then it's in a module. So yeah, I've got lid off, taken the fuse out. So effectively what we've got here is we've got all the cells facing inwards, then they're tagged together. So you see we've got like a first contact of first battery module here. So it goes into that module and it goes through all the cells of that module and then comes out here, and then you can see that's the divider between the modules, and then it connects to the next module and the next module and the next module and the next module, next module, and then round next module, next module, next module. So then this is your high voltage coming out of here, right? At this end they put an extra fuse, so it's got a fuse in it. That's its main output fuse, but there's another fuse here, and that, I mean, you don't, what's the point of having 2 same rated fuses in a circuit? Well, I guess you've kind of got a bit of a redundancy, but let's, you know, you have to massively overrate them to blow them anyway. But, you know, okay, they can say it's definitely protected at 275 amps, I think it is, by having that fuse. But additionally, by putting it there, that is part of the procedure. You take the lid off and take that fuse out. So we've got, you know, we've still got high voltage, but we've chopped it in half. Other batteries, the pull-out fuse is in the middle of the pack, and that's how they achieve kind of the same thing. With these, it's there basically, the fuse, and it takes out positive and negative. So we've got all our cells, it connects to here. This buzz bar goes into, that's a wrapped up buzz bar, goes into this box, which is fuse and contactors basically. So when you want to start the van and you get some clicks and it turns it on, these are the contactors, big fat relays basically, and it goes through a sort of warm-up phase, what's called pre-charging, and then it comes on. So then the power goes out of there, and you can see that it's going out of there and down to here, and basically what happens is, in this is a 4-pole isolator, so it breaks positive and negative. Okay, so we can see we've got our 2 main outputs there, and they're coming along and going underneath into this connector, and you can see we've got the other side of the battery goes into it there. So yeah, that's quite cool. That, I was just looking whether that's just a tray to hold it, or yeah, I think it's just a tray to hold it. It's got no connections. I thought it could have been a current sensor, but there's probably a current sensor in there as well as the contactors. Yeah, it's quite cool really, isn't it? This is pretty cool. I'm enjoying this. Yeah, good stuff. So yeah, just had a look round basically, looking for any moisture, corrosion, anything like that. Not seeing it. So yeah, not seeing anything too much of concern. Fortunately, this battery wasn't like tiger sealed, like using a liquid sealant that then sets. With like Nissan Leaf batteries, you have to cut the sealant, and then they provide, that's a big bit of rubber, right? I can put my finger here. So they put there's like a lip of metal there, and then the sealant goes kind of where that seal is, but then you can use a knife or something because you're against the metal protecting from the cells, obviously, and the sealant they use is really strong on Leaf batteries, whereas on this you undo the bolts and just the lid pops off. That's it. The bolts weren't that tight either. Actually, I need to look up the torque setting because it was just like boom boom zoom 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 with the gun, with my little baby gun. So yeah, I've had a good look round. That's first thing. No moisture, no corrosion. I was also just having a little bit of a look at the configuration. So this is obviously a BMS, isn't it? It's got one. The early ones I think had 2, one for each stack.
and this one just looks like it's got one. I have got the diagrams, but I didn't take in all the information. So, and then we can kind of see we've got on each module, if we go down here, so you've got that white connector there and there, so that's our voltage monitoring. So you can see that's obviously the interlock for the safety plug, but yeah, so that one, that cable there is going to here and feeding round and going back to that BMS there, so that can monitor all the voltages, and that's what was telling us that it was low. So okay, so we can't see any corrosion. Someone on one of the comments said that they thought the cables run, BMS cables run underneath the batteries and they get corrosion, but maybe they were referring to the earlier battery. But certainly in this one, the cables are on the top. Can't see any corrosion. Let's look inside the lid. That's always a good place to look, because if you've got damp in the top, I mean, there's nothing, but no, that is bone dry. Bone dry. Oh yeah, that's your fireman plug, isn't it? On the inside of. I'm just resting that against the wheel so it doesn't touch the body. A little bit of something on the lid there, but almost it's not damp. It's more like you know when you buy tools and they come with a tiny little bit of oil on it, like that, like a corrosion resistant sort of, I don't know, some thin oil or something on there. Anyway, so okay, cool, this is interesting. So there's no corrosion, nothing's damp, is it? Let's just have a good look down here. No, a whole lot of nothing. The plot thickens. So yeah, corrosion would cause it to misread, because we've got that cell that shows that it's about half a volt lower. What we need to work out excuse me, is whether that cell is actually low or it's just a reading fault. So I've got my meter and my marigolds, and what we can do is measure the voltage of each module, because it's quite a big difference. Sometimes you're looking for like 0.1 or something, but fortunately we're looking for 0.5, aren't we? Like 0.4, 0.5. So that should be really easy to spot, even if we measure a whole module. So we got, I love it. I just love it when they cover a buzz bar for safety and then they leave you like a test point. And sort of think, yeah, okay. I mean, that hole could have just made it 2mm, but you know, but then that's uncovered. I don't know. It's sort of to stop you dropping a spanner, or when they're assembling it, putting a whole metal case on top of it. I just find it hilarious, really. That just there's a safety cover with a whacking hole in it, kind of thing. Anyway, it's all good. Yeah, quite cool. But yeah, so if I measure here, and then sort of here to the one hole in that one, and then to the hole in that one, and then to the hole in that one, like that, we can actually get the actual voltages. Should we give that a go? Hold on a second. Oh, getting those gloves on and off. They're so thick, and because they're obviously sort of airtight. They have to be. You can get them on, and then trying to get them off again is almost impossible. Anyway, yeah. So, oops, pop up on my phone. Apologies. So 31.26. So that is the voltage of that module. All the cells in that module. So what I'm going to do is I'm going to go along each module and just check the voltage and see what happens. But that is our sort of reference, so I'll check that against a couple of other modules, and then we're just play an odd one out, basically, see what we can find. So I will come back in a mo. Okay, interesting update. So I was going along the modules, and it is actually low. It's not misreading. So they were all 31.27, 31.28. So 31.3 effectively, and we've got one 30.8, which is our 0.5, isn't it, basically? So yeah, and my probes are here, so I'm on this module here that's just under that end of the contactor pack. So yeah, we know this isn't the car misreading due to fault inside the BMS or corrosion on the wires or anything like that, because I'm measuring that module and it is low. The voltage of that cell is low. It is really interesting though, because like I was saying in the previous video, when you get a low cell, it's not like a Nissan Leaf just because they have a few battery issues, what you basically see, because the hold on a second, I'm just going to get a pen. Right, I just realised that vans come with 3 built-in whiteboards. What basically happens is the voltage relative to time, so if there's a constant charge on this cell, it doesn't go up like a straight line. So if you add, let's say it's a 100 amp hour cell and you add 10 amp hours, you don't get a 10% increase in the voltage basically versus to where it would be at 100%. It rises quicker at the start and then it sort of tails off, and towards the end these big lithium batteries are fascinating. So my line kind of tailed downwards, there's not really meant to be a dip there, but you know what I mean. It gets almost flat but not quite, and I've charged some batteries before and you can have a 0.1 difference in cell voltage, but you can have 10 amp hours in it. It's just crazy, but you're dealing with big cells. So what normally happens when you've got a weak cell, i.e. a cell that has less capacity than the others because it's old and it's just suffered more, whatever, is that the let's say they're all full, so they're all right up here, and you drain them a bit and not a lot happens, okay, and then you drain them a bit more, but because one has lower capacity, it reaches its cliff, its steep bit of its curve sooner. So at a lower voltage, a lower state of charge, the weaker ones are more apparent because they start to fall off this cliff. But that wasn't happening with this battery. What was happening is at a lower state of charge, it was actually having a less of a voltage difference. It almost looked like a better cell, but at a different state of charge. And we know this battery has had a battery repair from Renault. So it's quite interesting because I wonder whether that low cell is the one that Renault put in. They just didn't balance it much and thought, oh, it'll be okay because when they drive it, it'll balance. It's within, you know, some tolerance. But that hasn't happened, basically. What has actually happened is they don't use the van much. It doesn't get many full charges. It's really low mileage. And so that cell has just been able to deviate because it kind of has different characteristics effectively than the others. Kind of interesting, but we know where it is now. The next thing we're going to do, I'm just going to turn that off because it will start beeping at me in a minute. The next thing I'm going to do is I've got my internal resistance tester, and I'm going to see if I can put it across those modules, and that is kind of pardon me, like a test of the health of the cells, and then we will see what what readings we get basically. So yeah, interesting, cool. So I wonder whether Renault just did a poor job at the repair, but combined with the fact that this van is not used a lot because it's owned by a charity. They use it for a little bit of running around in London and that's it basically. So yeah, it might be the case that we just need to charge up this cell. Obviously we can't just charge that module up like that because we'll be charging all the cells up. We have to just charge up the one cell, which means we need to get that module out. Obviously the BMS is there, which is really useful, but just unclick that. So we pretty much got to take this lid off. So I've got the procedure, but it kind of looks like you unclip all of these, then those pieces have got to come out because they're on top of this lid, and then we've got this side of the lid. It looks like something like that, doesn't it? But yeah, we'll see. And then obviously that module is bolted down there, but I'm hoping it's not ones that are compressed into a stack. But hopefully, actually, if we get the module out, we'll be able to access the cells without actually taking the individual cells out. But we'll see anyway. So end of the day, we might have a module on the bench, and then we need to do a bit of charging. Okay. Yeah, I don't have a bench power supply quite of that rating. Anyway, we'll worry about that. We'll worry about that. That's fine. No, if we know what's wrong with it and we work out how to fix it, that's not really an issue. Cool. Okay. Right. I'm going to see if I can get some internal resistance readings, and I'll be back in a mo. All right. Okay, so I've been having a little bit of a play with my meter and thinking about taking this module out. And what I've done is I've taken out all the buzz bars. Basically, they have these are the ones with the little covers that were in the middle, and they fit nicely in there, actually. I'll just show you. So there's a buzz bar and a couple of screws, and actually it just keeps it together if you clip it down. So then they go between the modules across this gap. So if we look down there, we've got the module there. It's so difficult to see on that one, But yeah, and we've got, so we can see individual cells there, and we've got the main connection to the modules there. So they go from one module to the next, linking them all together. And I've just taken them all out, basically. So now what I've got is a box of 31 volt batteries, effectively. So this is now not a high voltage battery anymore. So now I can do whatever I like to it. I don't have to wear those stupid gloves that are impossible to get off. And I've totally made it safe. And this is sort of the difference between the way I like to work and the way the dealers like to work. So the dealers and the manufacturer procedure, they will design something sitting at a desk where it's impossible to kill yourself, but you have very little knowledge of what you're actually doing. It says do step 1, do step 2, put on your mask, put on your gloves, put on your gauntlets, put on your overalls, undo this bolt, put this bolt in a pot, put a padlock on the pot. You know, it's that kind of thing where it almost makes no sense. Whereas what I prefer to do is understand what's in front of us, think about what's sensible to do. If we don't understand something, we stop and we go and get the procedure, we do some research, we find out some information, and we come back with the knowledge of what we're doing and why we're doing it, basically. So now figuring out the configuration of this battery, see the fuse is in the procedure, and we know that that's a good step, and why as well. And then one of the next things we've done was taking out all of those, so I can touch this wherever I like, and I'm not going to kill myself. I can touch these as well, because they would have to all be linked together, which they're not, because all the buzz bars are in a pot over there. So yeah, have a little play with the resistance meter. I'm just kind of familiarising myself with it. It tends to bounce around, and then you get a reading off it. Nothing particularly significant, so no wild readings, which is good. And what we're going to do next is get the module out that's got the low cell, identify the low cell, and then we can test that cell. Obviously check the voltage, so we find the cell, and then we use the internal resistance meter. Well, it gives you the voltage as well as the internal resistance. Yeah, use that meter to check that cell to see if it's healthy or not, because if it's not healthy, we're not going to charge it. Whereas if that internal resistance meter says it's healthy and there's no visual signs, then we can charge it up, and it may well be related to what Renault did. So yeah, interesting. So I'm just going to refresh myself with the procedure, and I'm going to strip this battery down pretty much. I think it's these middle parts, obviously unclip all things. I've started labelling all these connectors and taking off the BMS. So like I know that one goes in there because that's number 6, and then I've made that one number 8. I can't remember where number 7 is, but oh, it's there. Look, but it doesn't matter because I know how to put it back together because I've labelled them all. So I need to do the similar thing with these individual ones as well, going onto each module, so that I know exactly where to put everything back. May get some white tape as well and tag them so they know where they're routed as well, all that kind of stuff, just so that we know exactly how to put this back together, and we'll be confident it's back in the right place, because obviously that's not going to be in the wrong place, is it? Because it's got an 8 written on the socket and the thing. So, you know, literally do it so that you can't go wrong, and then we won't go wrong. So that's cool. So yeah, we're getting under 5 ohms, 4.7, I guess about 4.5. So that's cool. I'll turn that off. Obviously this is giving me a resistance and ohms reading. Whatever you do, don't get a normal multimeter, put it on ohms and put it across a battery, because it might blow up. Okay, it'll get very hot. So yeah, that is a special type of meter to do that reading. So yeah, this is quite cool, isn't it, really? So it's one of these stacks. Is it this one? I can't remember, to be honest. I'll mark it in a second with a pen, physically mark it, and then yeah, start stripping this down and get it out. All right, cool. Okay, well, one mystery has been solved. So I'm just stripping this down, taking off all the metal parts and brackets with the contactor box and the BMS and stuff. And I noticed that these had sort of markings on, but that one didn't. So module 10 is our one with our lower cell. And I thought, oh, that's interesting. And then I thought, oh, that's got a different style of sticker on it, module 11. And then I was looking at these ones, which you can't read because it's upside down, and that's got 2008. And I'm like, okay, that's interesting. Look at module 11, 2021. So we know that Renault put a module in it, but it's not the one with the low cell. Okay. So yeah, that kind of makes me think that potentially we have got a weak cell, but it presents weirdly. I don't know. So I'm just going to waz this module out. But yeah, I just thought that was interesting. So there we go. We know exactly what Renault did with this battery
back in the day, they they put a module in it. And so they did, they just swapped this over. I mean, that's potentially what we could do if we could get one. That's the thing, it's a weird one where it's easier to get a battery than it is a module. But yeah, cool. Right, well, I'm just going to get this module 10 out and then we can do some tests on the individual cells, hopefully, if we can get to them. Right, cool. Well, as you can see, things have moved on. So I obviously have that module out. We're slightly missing a step here, apologies, in that I've had a little bit of a coldy fluey thing, just tail end of it, and I got this module out and did a load of tests on it. And I was trying to basically record a video, but I couldn't stop coughing, which was a bit problematic. So I didn't, so we've moved on. Basically, so I got this module out, I did a load of tests on it, saying basically voltage first of all. The voltages were spot on what the car data showed, so there's no BMS fault in that sense. The voltages are all reported correctly. It is genuinely low, and it's the top cell there. And you can kind of see how the cells are laid out. So there's one there, one there, one there, one there, and then we get obviously both tabs. So that's the output that goes down to there, and then the tabs are folded together there. So that's the one from that top cell, and then the tab from that bottom cell, and then the cell is there, and then the tabs are both folded onto that buzz bar for going onto this cell, and then there's that cell, and then you get the tab from that cell and the tab from the next cell, and that's how it kind of feeds on down, 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 and then it comes out of there basically. So yeah, did voltage tests, did some internal resistance tests on that cell as well, and basically the health of the cell shows as good. Okay, so I also shared all the really low internal resistance. If you want the actual figures, so these cells varied between about 0.7 milliohms and up to about 1.8 milliohms, so all pretty good. And actually our low one wasn't the highest by any stretch, so it looks to be healthy, which is interesting. So yeah, I shared all my data with the guy that I know who builds custom EV battery packs, just to get his second opinion. I mean, it looked to me like it was safe to charge, but I just wanted his opinion because I respect his opinion. And yeah, he's a really smart guy. And yeah, he said he would charge it as well. Looks safe to charge, so that's cool. And we are doing so. So basically, I've got my little lithium balance charger. I'm just charging one cell, so I'm just literally using the output and straight onto that cell. I'm doing it in my kind of storage area where I keep, you know, take stuff apart and keep stuff. I've got a bag because it's a little bit dusty, and also I don't want any kind of damp to come in here because it's unheated, so I can kind of wrap that up, you know, once yeah, once I've sort of finished recording, I can just make sure it's not going to get damp or anything. But basically, I did think, you know, it's pretty safe to do in the workshop, but because this cell, I've been charging and discharging it repeatedly with obviously no ill effects, but there's always a risk. There's a risk of this charger, there's a risk I don't set it up correctly, there's always a risk, especially doing it directly rather than in the car. So better to be safe than sorry. So we are in the slightly dusty storage area, but that's cool. I've got an extension lead running in here because it's got no power, but that's cool. So I've got this on lithium ion mode, so this isn't going to stop. The others are sort of 3.9 basically, about 3.9, 3.91. This won't stop till 4.1 because it will try and get it fully charged, but I'm going to keep an eye on it basically and just get it slightly above, and then I'll disconnect it and just let the voltage settle because it will do naturally. Just keep an eye on it with my meter. It's interesting, so if we look, it is, so on the charger it's showing 3.6 volts, okay, with 3 amps going in, but my meter is showing 3.47, and that's the reason I've got that meter separately, is because this is charging at 3 amps. There is resistance in these leads, so this is never going to give me the exact correct voltage. Generally it doesn't matter, because as the battery becomes fully charged, it will reduce the current, so it kind of gets more accurate as it gets more full, if you see what I mean. But you're seeing the sort of supply end of the circuit there. There's obviously a bit of voltage drop across the leads, and that's basically why the battery itself is 3.47. So yeah, I quite like these. They're quite simple to use, but still, you know, and it's quite powerful, this one, so this can go up to 6 amps as well.
I will probably knock it up because otherwise we're going to be here forever. But I'm just getting this set up, or just playing around with the settings and things, just familiarising myself with how it works. So yeah, that is the shape of it basically. I said to the customer that we're going to proceed to charge it. The proof of the pudding with this will be whether the van works long term once we've charged this. So we could have a weak cell that's draining itself over time, albeit in all the time I've had it, it's a barely noticeable discharge. So what we could have is an incredibly small amount of discharge, but because this customer is a very low use customer on the vehicle, you know, it's just the van just hasn't balanced it out because their usage is so low. So you know, this may well work. And the guy I sent my readings to that builds the custom battery packs, he said what he would do is actually charge this up, put it on the shelf and leave it for a month. And if the voltage hadn't dropped, it will settle when you finish charging it. But you know, after 24 hours, yeah, okay, now it's definitely settled from its charge. He'd leave it for a month and see if the voltage drops, and that's what he'd do. So I don't particularly want to wait for a month, but what I will do is get it back in the van and maybe leave it for a little bit of time just to see kind of like whether it drops at all, and fundamentally then just let the customer kind of use it really and just see if it works. Just try and get them to just cycle the battery a little bit more often and see how it goes. So I'm going to let this run. I'm probably going to up the rate because we're going to be here a very long time. I reckon I need to put about 40 to 50 amp hours into it. I've had to turn off the maximum. There's like a max on this, but I've had to turn that off because it's set at like 6 amp hours max, because obviously it's designed for like RC battery packs. And I'd have something bigger if I did this a lot, or something that I could set the exact voltage, but I've just got this set to charge, and I'm just going to keep an eye on that basically. And when it gets a little bit above, yeah, then just go for that. I can always discharge it a bit again or whatever, but I'm kind of going to do it the slightly faffy way, but it's safe, and it'll work, and that'll be absolutely fine. So yeah, I think you might be able to make custom programs and all that kind of stuff on this, but I don't use it that much to warrant faffing around with it really. So yeah, we're just gonna yeah, let that go. I think I'm just gonna let it run at 3 amps and just make sure everything's happy. Obviously make sure we don't get like any heat or anything like that. I'll go and get my laser thermometer and keep an eye on it and all that kind of stuff. But yeah, just kind of like make sure that's happy. And then yeah, and then I'll probably up the rate. But yeah, cool, that's all good. So yeah, I'm just gonna let that do its stuff, and I'll catch you in a bit. Okay, so we've had a couple of charging sessions on this battery, and so we were at 3.5, weren't we? So around about 3.5, so we're at nearly 3.7, and the other cells are about 3.9. So we're getting somewhere. He's soaking up a lot of juice, and I just stopped it because I realised there's a high-pitched whine which really comes out on the camera, which some people might find slightly painful. But yeah, this charger is working really well. It's really pumping in the juice. What I've been doing, just to make sure that nothing too exciting happens, obviously I've been kind of keeping, you know, an eye on the temperature and voltage and things. I mean, this won't overcharge it, but it will get it to more than 3.9, so I don't want to kind of fully charge it. Basically I've been using the capacity limit on this, so I set it to 10 amp hours, but it was still taking quite a while. I've upped that to 15 amp hours now, so excuse me. Yeah, so basically I'm just going to keep pumping in some juice. And yeah, I kind of wasn't entirely sure what sort of charge rate to go for. I mean, these cells can cope with kind of, yeah, massive rates. This can go up to 6 amps. I don't want to do anything too exciting sort of thing. This is going to get warm, you know, you kind of want to limit it. So I think I went for about 4 amps at one point, and then kind of limited to about 3 max, and been on about 2.5, but I might just up that to 3 just so I can get another, yeah, another fair amount of amp hours in it now. And yeah, it's quite smart, this charger, actually, if you've not seen these before. So yeah, I'm telling it that I'm on 3 amps, and I can tell it what kind of lithium battery it is. So if it was 2S, 3S, whatever. I mean, if you were charging like that, you'd be using the balance connector, so one of those white ones, to monitor the voltages, whereas I'm not, because this is only 1S, effectively 1 cell in series. But this charger could charge up to 6 cells, and it would balance charge them and get them all the same and everything, which is quite cool. Yeah, it would give power through those, and then it would balance through the little connectors down the side, the little multi-plugs. But yeah, once that's done, apologies, there is going to be some squealing. in a second. Actually, it'll do this bit first. So it does a check. So what's happened here is I've told it I've got one cell in series, so one SCR, and what it can, what it's seeing is one in series. So if you get that setting wrong, that's where you get the point to charge. Now it's gone back to the first one. Yeah, I'll wait for a second before I kick that off. But yeah, it's working. It's working really well. I think my leads are still on there pretty good. Yeah, cool. So this is working well, but yeah, it has soaked up a lot of juice. So to get it halfway, I've probably put 25 amp hours into it at least, which is quite a lot. So yeah, he obviously is concerning that this cell was so far out of balance with the others. Is it just their use case? Is this cell weak? Yeah, it's really hard to tell because the health test's good. Very, very difficult to tell. I kind of have a feeling that they try and keep this fan in the middle because they heard that's good for EV batteries, and then they take it for a little drive and then they just plug it in for half an hour again, and it kind of never gets to full. So yeah, maybe this cell's got like a tiny, tiny, tiny self-discharge, but just not balanced out for a very long time. So we get our beeps, and we get our beep, and then we can confirm that. And then that will, this voltage obviously starts going up because we're at the load end, but this down here in the bottom right is the milliamp hours. So that will start racking up fairly quickly, and obviously the time there. But yeah, I've got this on a 15 amp hour limit, just so that I basically don't go above that. Yeah, above that sort of 3.9 that I'm looking for. It's kind of so that I can charge fairly quickly, basically, but not worry about it going over. So I can get it in sort of rapid chunks. Very difficult to do this with one hand, but yeah. So yeah, that doesn't go up much. Obviously the charger there says 3.83, but that's 3.695. There you go, cool. So yeah, it's working well. It's just sucking up a lot of juice, so, but the proof of the pudding will most certainly be in the eating of this job. So, right, that is covered up. I'm gonna leave that, and then yeah, see how that's doing later. All right, cheers. Okay, we are really getting somewhere now, so let's get that way you can see it. So I've started limiting the charge to 5 amp hours instead of 10, and 3.905. So the next cell is at 3.906, and then we got 3.91, 3.907, 3.913, so that's a little bit more, 3.905, 3.909, and 3.913. So yeah, we are now basically matched with the lowest one in that group. Obviously there's a difference here between the 3.905 and the not that one, and the not that one, the yeah, that one, 3.914. So 905, so that's 0.09, isn't it? Yes, because it's got 0.5 to 14 there. Yeah, okay. So what I might do is just put like one more amp hour in, just to make sure that mine is basically balanced up with the highest ones. That is stopped charging for a couple of hours, but that may settle a little bit. So I reckon 1 amp hour, and then we'll be about there, which is cool. So I want to start putting this back together tomorrow. So I've put it on a 1 amp limit. So if we go through to here, so my lithium type is set to lithium ion. There's a sort of timeout check, nickel metal hydride settings, temperature stuff, blah blah blah. So my timer is off for safety. Capacity cut off, I've put down, it's on, put it down to 1 amp hour, 1000 milliamp hour. So yeah, I think I'm just going to stick that in and then let that settle. Yeah, because that's quite a small percentage of the capacity of the cell. Should I do it at 1? Or should I just make it? I think what I'm going to do, because I've got time, I'm just going to put it down to 0.5 amp hour. Yeah, let's go for that. Let's go for that. So lithium on, yeah, 1 amp. And we got 1, and let's go. So yeah, because I don't really want to go over, but I can afford to. Obviously that's only going to take half an hour, so I can afford to check it again. Yeah, cool. What I ideally want is it to be one of the highest, because it may drain again, and we want to kind of give it the best chance really. So a little bit higher, it should be able to balance 1 down, not a big issue. But yeah, we're about there. Fantastic. So tomorrow I'm going to start getting this battery back together. Yeah, cool. So yeah, there's not been any heat or swelling or absolutely anything exciting at all, basically, during the charging of this battery, which is sort of what I'd expect, really, because I've been charging and discharging this one. The health was good. And yeah, we will see. That's a temperature sensor, by the way, just sitting up there. So yeah, cool. All right, good stuff. Well, I'm going to just let that charge, and then next step is get it back together. Cool. Okay, I am going to do one final charge. So I've got it really close, and actually what it is kind of in the middle of the others now. So let's put that the right way around. So we're at 3.912. It was 3.911 when I first checked it a minute ago. So the other 3.906, 3.91, 3.907, 2.913, so that one's a little bit above, 3.904, 3.909, and 3.914. So I'm trying to get mine to be sort of the highest of what I've got, maybe just a tad higher. A, because that voltage may well set a little bit, but also because this one, if anything, is going to drain a little bit. So I want it to kind of be the highest. So yeah, I'm just aiming for a tiny little bit higher. The battery should be able to bleed that current out in the normal kind of way. And yeah, if anything, I want this one to be higher because it may have just a tiny self-discharge. So I've been trying to think of what other things could have caused this, just to make sure we're not missing anything. Is there anything we should check while this battery's apart? And I thought, well, it's monitoring the battery through this connector. So I thought, what about if the bleed resistor was stuck on? So there was a tiny drain, but it was from the BMS. So that's something I can check, but I think that's a very slim chance, to be honest. You know, we know this battery's had one repair done already. We're now attempting to fix it again, but the van is such low usage, you know, I've kind of never really seen that before, but it's highly likely this issue is caused by the low usage. So I think that's a pretty slim chance, but I'll try and test for that anyway, see if we can work out how things are connected. Yeah, and then I'm going to check how many pins on there, see if we can get a wiring diagram. And yeah, just double check for that while we're there, just kind of thinking of anything really. But yeah, I think this is going to be a case that cell just has a tiny self-discharge, and they're just not balancing it out. But yeah, the proof of the pudding really is going to be in putting this back together and seeing what happens. So the van needs an MOT, so I've agreed with the customer I'm going to keep the van to MOT it. So it'll probably, I keep forgetting to ring up and book an MOT because I've been busy. But I'll be down at that my MOT place where I take them tomorrow, getting a different car MOT'd. So I will book an MOT. That'll probably take a week, and that'll enable this van and this cell just to sit for a week. What I'm basically going to do is put it back together, drive it out of the workshop, park it up, and then just leave it till the MOT. Obviously look at the data once I've parked it up. What you kind of need to do, because obviously I've charged it and then there'll be a drain on it when I drive to park it. So the voltage will settle, whether it's had a charge or it's had a load, it will then just recover a little bit. So if it's had a load on it because I've moved it, it'll be a little bit depressed and then it'll just settle back up. Similarly, if I've charged it, after I've charged it, it will settle back down again. Obviously, the faster you charge them, the more they settle. I'm ending this charge really gently because I don't need to do anything else, basically. But, yeah, so once I've driven it, the voltage will be slightly depressed and then it will settle back up a tiny bit. So let's say, I mean, I'm not going to drive it far. So, you know, 12 hours, something like that, should be plenty enough time for that voltage to settle. And then I will take some screenshots of the data and leave it for as long as I can, whether that's a week or whatever it is until the MOT. And the next thing I do when I get in the van is look at that data. And I think the Kangoo, from memory, is like the Zoe, that it wakes up the high voltage system straight away when you open the door. I can't. I'm sort of doubting myself now. I'm sort of hoping it doesn't really, because I don't want to put any load on that high voltage battery. I want to read the data before there's any load. So yeah, but yeah, we'll see what we can do. in terms of seeing what the data is and then leaving it for a period and looking at it again. So yeah, we'll see what's occurring. So I'm just going to let this do its final little charge. I'm just putting 200 milliamp hours into it now, so it's really tiny little bits, but it's good to get it really, really nicely balanced. If it was just like a replacement module or a replacement cell and I was getting it close, that would be absolutely fine because it's within the others, but I want it to be like just the highest in the pack, basically right up the top. So this is obviously just one module, so the others are probably, you know, there's probably some that are a tiny bit higher. So if mine's a tiny bit higher than these, that's absolutely perfect. So, but yeah, cool. So I'm just going to let that do that. It's done 53 milliamp hours, and yeah, then tomorrow I will get this back into the workshop, start rebuilding the battery, get the battery back in, and then we'll yeah, make sure it's okay, park it up, book an MOT, and go from there. But yeah, the real test is going to be in cycling the battery, making sure the range is then good, that it works well, but then over the next month or two, really seeing how it runs. If the customer's doing some good full charges, yeah, then hopefully that will be enough. If not, we'll have to find another battery and put it in. It's a little bit silly, and I was chatting to another guy today about this, it's a little bit silly because I've got 11 modules that are absolutely fine, and I've got one that's a problem. If I buy a battery, I'm going to have 11 spare modules, aren't I? So yeah, okay, I can fix 11 more Kangoos, but it's just a bit silly, isn't it? You're buying a whole battery just to get effectively one cell. I mean, that one cell, it's laser welded tabs into a module, and as soon as you open these, they're kind of compressed into a pack, so they're pouch cells in there, compressed in, so you can't really open these and, you know, take them off or anything. You have to fit a module. But you know, if this one turns out it is no good and it's got to be replaced, I only need a module. I don't need a whole battery, but I might have to buy a battery because that's the only way to do it. But anyway, there's a gap in the market for someone to start a workshop and split batteries and fix loads of cars. So yeah, there we go. All right, so I'm just going to let that do its thing. Back tomorrow, and we'll put it back together. Cheers.
Okay, the module is back. Apologies if yeah, there was quite a lot of squeaking in those previous videos. I didn't quite realise that high-pitched whiny squeaky noise actually occurred when the charger was on, not only when it was charging. But yeah, hopefully that was okay. But yeah, we are back. So I put a tiny little bit more juice into this cell, so we are now at 3.91, and the next one is 3.905, 3.91, 3.907. Yeah, I think this one was a little bit higher. Yeah, 3.914. So we're not quite at the highest, but good enough. Good enough. So yeah, we're well in there. I have to say, this just charging it up usually is not a solution. And a guy rang me and said, "Oh, I saw your previous video, and I've got a Zoe, and it's got a low cell, and you know, sort of like, you know, was just thinking about what the options were." And in his case, charging it up is not an option. His is only 250 millivolts out, interestingly, so it's not as far out, but he's been using the vehicle regularly, and if the car could balance it out, it would. Whereas I think with this vehicle, there's the potential that, because they hardly use it, this might have a tiny drain that the car could balance out if it was balancing regularly, i.e. being fully charged and doing that balancing phase at the top where it drains the high cells, but it just never does that. So, and I mean, this might even not be a good enough solution in this case. This vehicle may come back in a few months because this one has dropped again, but we will see. And that's the only way to really tell, is to kind of yeah, see what happens over time, see if this drains. But yeah, just kind of take it as read that charging them up isn't a solution. I don't want like a million phone calls of people saying, "I've got a low cell, can you charge it up?" Because that's sort of like 99 times out of 100, that is not the solution. Just in this real edge use case scenario, it may be. So we will see. So yeah, I've got my module back. I've got to just put back together this sort of front plate, and it's got a couple of buzz bars so that these are the kind of like ends of the module, the top and bottom, and then there's a couple of little buzz bars, so you get your 31 volts there. Quite cool little modules these. Everything's quite accessible. Little balance connector, if I move the camera up. Yeah, so it'd be quite fun really. But I'm hoping at some point I do a battery repair and get left with a load of modules, and I can do something fun at home. Yeah, we shall see. But yeah, so I've got to get these back on the front, so that's all kind of back together, and obviously get the module back in. Then I've got my little buzz bar things that I had before, so a little buzz bar in a box, that's quite cool. And then I've got metal clamps and all that kind of stuff. Turn it back into a high voltage battery rather than just a box full of modules, which it is at the moment because they're not linked together. So yeah, I'm going to get this lid off, get this module back together, and get it back in that van. Yeah, cool. Right, let's do it. I thought I'd just show you this for a second because it's quite a cool sort of piece of engineering, really. So this is the front panel for the module that sort of slides over there, and this is where the little buzz bars that I was showing before, they were sort of inside here. I'd taken it sort of everything apart because I wasn't exactly sure how it comes apart, so I obviously undid all the things to make sure it didn't break anything. But this is actually a separate module by itself. It's got these orange parts so that you put it over there, and then the buzz bars sort of bolt on underneath. So that slides over there, and you can see there's a bolt hole there. There you go. So when I fully clip that in, I'll be able to just bolt that on. So when they're manufacturing it, this is just one piece, but it's got the buzz bars inside. But the buzz bars are shielded on the back from the modules because it's got that back plate. So when they're manufacturing it, they just pop that on the front and put the two bolts on. I'm going to do in a second. I thought that was quite neat, really, because you've got these orange covers that are protecting the sort of those terminals. So from the outside, all you've got is that these sort of you know, the two ends, the positive and negative of all the cells. Yeah, and that just sort of clips on and bolts on. I thought that was quite a nice bit of engineering. I thought that was quite cool. It's sort of easy to use but functional and safe as well. I was almost tempted to go and show the wife, but you should probably give me that glazed expression. But yeah, I thought you might be more interested. Anyway, so I'm just going to clip that on and then bolt that on. I thought that's quite cool, really. All right, good stuff. I'm just getting this battery back together. I've got all the metal covers kind of roughly in the right place, just sorting out this contactor area, which is quite cool. Really appreciating the engineering of this battery. It's neat and it's safe, and it just kind of all slots together, and there's a little bit of space around it. I quite like this. Yeah, it's quite cool. Just thought I would bring up an interesting point, which relates to the Zoe, which a lot more people will have Zoes. So on a Zoe, the isolator plug, which this is the one here. Hang on, I'll just take the cover off. Okay, there we go. Sorry, I'm not an octopus, so I need two hands for that. It's got a little, this slidey thing's a bit of a faff on these. So there is the isolator socket. It's got 4 connectors in it. Don't worry too much about that. But in the Zoe, the socket which is in your driver's footwell on the UK cars, there is full battery pack voltage in that socket on a Zoe. Okay, so it is pretty dangerous. It's obviously on the floor, so any necklaces or anything you drop, if you're using a screwdriver or a little metal body clip tool to take up the sort of quite tricky cover that's there, if you touch any of that in there, you're gonna die. Basically, that's the risk. There's full battery pack voltage. There is only one of those big fat fuses, one of those like that. And that's not going to blow. You're going to blow if you go across that. So with the Zoe, the isolator socket is quite dangerous. With this Kangoo, it's not, and there's a specific reason for that, and it's kind of interesting. So the way the battery's wired, we've got our 2 main terminals here. I can use my fingers because I've taken out all the interlinking buzz bars, haven't put them back yet. So this is just a box full of 31 volt modules. So there's a fuse at the other end, but that just, you know, it is just the fuse. A fuse, because there's no one here. So yeah, I've got my main positive and negative. Now on a Zoe, they go straight to the isolator socket, and they go through the isolator socket, and then they go to the contactors, which are the main relays for the battery pack. On a Kangoo, it's the other way round. So we can see we've got a positive and negative here. We can see that one is just going straight on. That's the blue one there, I think, isn't it? Oh no, it's the black one, sorry. So you can probably see this better than I can. I have to move the camera out of the way. So yeah, so that's more than likely a negative, coming off the battery and goes straight into the isolator socket. So on a Zoe, the positive one goes straight down as well. But on this Kangoo, it loops round, it goes through this fuse, it's going through contactors. There'll be a pre-charge contactor, and you don't need to worry about that too much, but it's got the big fat relays that turn the power on. And then it's coming out the other side, and you can see it's going down, and it's there, isn't it? Is it that one? Yeah, it is. It's on this one. So we've then got, once the contactors are on, we've then got our power going into the socket, and then it's coming out of these ones here. Slightly difficult to see. It loops downwards, goes under there, and then it comes to here, and that's the main battery
connector which has got a glove over it just to keep it nice and dry and not get any dusty, you know, any dust in it. So with a Zoe, you have to be really careful in that socket in the footwell, okay? And that is why there is full pack voltage there. It's quite useful for me on a Zoe because I can do some testing. I can take a high voltage reading from the battery pack. I can do various tests through that socket, but I'm doing that with my high voltage gloves on and being extremely careful. Okay, so just be really aware that if you're, you know, pulling that isolator out of the footwell in the Zoe, you have full 380-ish volts right in front of you with only a massive fuse to protect you. Okay, yeah, on a Kangoo it's the other way around. I had a Kangoo previously where I suspected the contactors, or one of the contactors, was stuck on, and I could actually read the pack voltage through the socket, and that proved the contactors were on, because I shouldn't be able to do that, should I, when the van is off and the key is away and it's all switched, you know, all sort of switched off, shut down, vehicle's just sitting there. If my positive and negative, one's going to the socket, the other one is going through the contactors and out the other side to the socket, if I can read the battery pack voltage through the socket, I must have a stuck contactor, like a stuck welded relay, welded main battery relay, and that's what that van had. So I hadn't looked inside at that point because this was a couple of months ago, and this is the first time I've had a Kangoo battery, a part of this generation anyway. But I looked at the wiring diagram and worked that out basically, and compared it to another Kangoo. So I had two Kangoos sat there, one which worked fine but needed some mechanical repair, which did not have a voltage on that socket, the other one which had a fault and had a voltage on that socket, and I knew that the contactors were then welded on. In that case, it actually drained the pack right down as well. And I actually did some sort of tests on the battery, taking out like a tiny little bit of current just to prove that there was a battery behind that, because it took the current and the voltage went up a tiny little bit. We're talking like, we know, 1 or 2 volts kind of thing, but just to prove that there was definitely a battery behind that. So yeah, just a little bit of interesting sort of architecture and just a little safety warning about your Zoes. But yeah, I'm really appreciating this battery and how it's laid out. It's just really neat and easy to work on. So yeah, cool. I'm gonna finish getting this back together, and then we'll get the cover on and put it back in. So yeah, this is the point where you got to be 100% sure that everything's clipped in, because we really don't want to put that battery in and then find out it can't read one of the modules or something because one of these hasn't been clipped in or whatever. So I've put those in and I've been checking those, and then obviously you could do the contactors. We've got that BMS to put back on, but yeah, we labelled everything before, so it's all good. These numbers are all my numbers, and then they correspond to, I've written numbers on these connectors as well. So it should be all good. We'll get it back together and see what happens. All right, cool. Well, top tip if you're putting a Kangoo battery back together, make sure you've got these temperature sensors, that one and that one, coming out the right place, because otherwise, when you realise afterwards, you have to undo all these bolts again and lift that up and wiggle it through the right place. So yeah, top tip. But yeah, so you know what I've been doing for the last half an hour. So yeah, I think this is all pretty much clipped together. Just going along, checking. I was just looking back at a photo just to make sure everything's kind of routed correctly. So I've got BMS connectors in here, so I've had to unclip some of these, so I'm just going to make sure they're all in. Obviously I can do this with bare fingers because I've still not got my little linky buzz bars back in. So this is just a box of 30 volt modules. Other than at this end, I have got 62 volts because I've put the fuse in there. Nice little bit of design actually, this little fuse cover. So it's in a plastic housing, and they give you this like a nice floppy silicone cover. But yeah, that just covers that, and then they just fit into there. That, I don't know who designed that, but that's nice. That's a nice bit of design. It's functional, vibration resistant. That, I quite like that. And I suspect there's also more functionality in terms of these fuses are designed to contain so many thousand amps short, but that's presumably providing some heat resistance as well, just in case that fuse gets hot. You know, all this has been really thought about, and you get points. You obviously think about the vibration of these buzz bars and cables. So you see behind that one there's a little just in there, there's a little sort of stay in there going through, a little sort of clip through, a bit like one of these. You see you've got that sort of clip that goes down and pops through. They've got one there, but then there's not one here. So they've obviously decided to wrap this, because in case it vibrates a lot and bumps into anything, Yeah, I mean, they could have put, yeah, maybe could have put another hole in here and put one of those stays in there. But yeah, it's just quite cool, really. I quite like this. Quite neatly put together. Yeah, another one of those rubbery sort of covers down on there on the connectors for the service plug. But yeah, that's quite cool, really. So yeah, what my plan was, which is what I like to do with these, is to pretty much get them back together and then go and have a cup of tea or lunch or something, have a break, and then come back and just recheck everything, basically recheck all the connectors, make sure everything's in. You can see, look, I've undone this. This is part of the rechecking. I've undone those before I've to retrieve those temperature sensor wirings, so they need doing up, and this is just part of the process. We're just double checking everything, make sure everything's clipped in. See, these have all been out. I looked back at a picture to see how this was routed, because I had it underneath and it's meant to be routed over the top. But yeah, we're just going to get it all kind of back together properly, and then when we're happy with that, then obviously we have to do that more carefully. So yeah, quite cool, really. We should do that in a sequence as well, because if we start from that end, then we're just building more and more modules up, aren't we? I mean, we are kind of, but if we start from this end, we've got two separate, then we'd end up effectively with 3 batteries at a lower voltage. So just to be a little bit safer. But yeah, it's quite cool. These are quite neat as well. Quite nice little design. So a little cover in there, and then they go down onto there. I'll look back and refresh my memory which way round they go. I suspect they go sort of that way round, but yeah, and I look back and yeah, we'll go for it. So, and when I'm doing these, I have sort of fairly sort of particular working practices, so I don't put any tools on the top of there. Obviously I've got some insulated tools and all that kind of stuff, but you just, you know, you just don't put them on the top, because you could obviously cause an issue if you short across these batteries. They have massive current supplying power, so you just don't want anything exciting to happen, basically. But yeah, so final checks, I need to obviously do those up, just double check all the other bolts and make sure we're all good, and all the connectors and everything. Obviously everything's been labelled, so it's pretty easy. You know, I'm fairly sure that number 8 goes into number 8, and similarly sort of along here, you know, we can kind of tell what goes where, and numbered all the sort of connectors for all the modules as well, so I know that that one wraps around there and that one in there. You can kind of see from the cable as well when you go to put it in. I mean, that doesn't want to go over here, does it? He wants to go in there, so that's pretty obvious. But also it's got 11 written on it, and that is module 11. So, you know, you just kind of like making sure. I just hate it when I go to a garage and they've just like, they give you a box of bits, you know, and they're like, oh, I'm not sure what's wrong with it. It's like, well, yeah, I think you're not sure how to put it back together either, so you've got 2 problems there. But yeah, that's just the way I do it, and yeah, it's all good. It's all good. So yeah, there's quite a bit of space in here. But yeah, that's because it's designed to fit in a diesel area of a diesel tank, isn't it? But yeah, cool. Right, so I'm just going to do my final checks. Oh yeah, I would normally like to get a cup of tea. Unfortunately, the missus is on a Zoom on the dining table, so slightly annoying, but there we are. Hopefully she'll finish soon and I can do some final checks. Maybe what I'll do is just do my sort of yeah, do some checking over, get those in, and then I'll go and hopefully she's finished, have a break, and then we'll do our final checks. Yeah, cool. Right, let's do it. Now things have progressed, as you can see. So I did my checks, it's all good, got the lid on, pushed it back in, and it is just about getting into place. I need to yeah, just make sure it's lined up, get it a bit higher, and because as you can sort of see there, you can see that silvery bit, and then that needs to go right up there. So yeah, I need to wind it up a bit more, start getting some bolts in, and then move my trolley out of the way, the final bolts, and yeah, plug it in, and then just make sure it's happy before I pull the covers and do up the bolts finally. So yeah, I'm gonna crack on with that. It's all good. Right, let's do it. Okay, so I've got the turn that light on as well, battery sort of loosely in, the bolts in, strap cables on. Okay, cool. Yeah, so we've got no faults coming up there, and yeah, it starts, so that's cool. Cool. So I'm gonna have a quick look on the diagnostic machine. We've obviously not caused any faults, which is good, so I can basically carry on and you know, put the battery in properly. I'm just gonna knock this off while the diagnostic machine warms up. Come on. I'm just taking it off charge. Sometimes it takes a couple of goes to wake up. Right, is it waking up? Yes. I'll be back when it's alive. Okay, well that takes a really long time to scan. It scans for every ECU on any Kangoo, basically. So, like, you know, it's looking for the urea dosing module and stuff, which obviously this vehicle does not have. But we were number 80, weren't we? We were having issues with. I mean, this should be absolutely fine. But there we are. It's actually showing it as a tiny bit lower than the others, actually, which is interesting. But, you know, tiny bit. So I don't think that's going to be a major issue. We are there or thereabouts, aren't we? A few millivolts. I think that's okay. It's interesting that, you know, where I was seeing sort of differences, it's not really. So I was seeing like 3, 9, 14 on some of them, wasn't I? But yeah, it does show mine as lower. Interesting. Right, well, it has got a bit of load on it because it does put the DC-DC converter on just with the ignition on, so not the van actually running. So that's kind of interesting. But yeah, okay. Maybe it does drop a little bit more under load. Didn't seem to before though, did it? Anyway, I'm going to put this back together. So I've booked an MOT. If I turn that one, oh no, you're still getting the light off that one. I've booked an MOT for Tuesday next week. It's currently Wednesday, so it's going to get well, tomorrow I'll move it and then park it up, and it'll get 5 days of not moving, and we'll see what happens to the voltage of that cell, get an MOT, and then we can do a proper road test. And yeah, and then just over the next couple of weeks after that, just see what happens. So yeah, I'm going to put the 12 battery in charger overnight just to make sure that's all good, because that was a little bit low. Put it back together tomorrow, move it out, and yeah, it's all good. Right, all good so far. We shall see. Cheers. Okay, so I'm just getting all the covers back on and everything, and I was just talking up the battery. So I looked up the torque setting, and it's 62 Newton meters, and you are my witnesses. That is what it says, and it's definitely Newton meters because we've got Newton meters here. 62, and they're definitely the bolts, because we've got the 3, this is on the back, and then there's one on that side and one on the other side, which is that one. Mental. It's got 2 little ones, or it's actually got 3 little ones actually, now look at it. Yeah, so it's got one in the middle on the front, which is a little one, 21 Newton meters. Okay, that's sort of like barely hand tight. Yeah, then it's got one on the other side and one here. They're next to that pin, so there's a bolt next to that. Normally this kind of thing is for when they're manufacturing it, they use that pin to sort of locate the battery, and then that bolt is purely there just to sort of fully locate it, if that makes sense. And then the other ones will line up and they can waz them in. But 62, it's not very high, is it? That's what it says in black and white. Okay, yeah, there you go. I'll try and double check this with another source, but yeah, anyway, okay. So I've just got this cover back on. No, this one, sorry, I've just got back on at the back. So I've got this front one to do. I've put that cover back on, the earth strap's back on. That is on top of the high voltage cable, so that's not an issue. So yeah, okay, fun and games. I'll get these covers on, and it's all good. Okay, well, don't worry about that. All will be explained. So basically, it's related to that. I have got the covers on, driven the van out of the workshop, and parked it up. It's a little bit out of the way so it can stay here until the MOT on Tuesday. So it's currently Thursday, so not loads of days, but a good few. So I've obviously put some load on the battery to move the van. But I've now removed the battery isolator, hence it gives you electric motor fault. Nothing to do with the motor, just generic drivetrain fault. Something is wrong in the drivetrain somewhere. Purely because when I want to check the battery voltages with the diagnostic machine, which is just doing its scan, as soon as you turn the key, it starts the high voltage system, starts the DC-DC converter, and it puts load on the battery. And I don't want it to do that. I don't want it to, apologies about the rain, we are under a bit of a tree as well. Yeah, I don't want it to put any load on those cells at all. So we're just going to have a look at the voltages. That's finished doing its scan. It's got faults just because everything's been apart and stuff. So it's got lots of 12-volt battery's been off and stuff. So it's got lots of memory faults. So that's not an issue. But yeah, what we want to do is look at this. But bearing in mind that I have obviously just put a bit of load on it. And it's showing a tiny bit lower, isn't it? Which is interesting because it was sort of there and abouts with the others. Is that a concern? So we're at, that one's really bouncing around as well, more than the others. And the others are bouncing around as well. So that is an average of about 3895, isn't it? And they're 3900. So 895, well, about 903. 895 to 993. So we're 8 millivolts different, okay? And 893-ish. 895-ish, didn't we? We said 2903. 3903. So 3895. So that, oh, that was good. Tap to the machine. So that may change a little bit. There you can see my interlock safety lockout plug is open. So that may change a little bit, but we really want to see whether that changes significantly. It may change just because we've driven it, so we've put some load on it. I had to drive it up a slight little incline just to get it to where it is. So there has been load on it, but let's see what happens to that voltage. I'm hoping that's not going to drop. I'm a little bit surprised it shows as lower than the others. But there we are. That's how it is. It is definitely close enough. 8 millivolts. That's not going to cause any issues. Yeah. And then we shall see what happens. So yeah, I'm going to leave this. It's going to be 5 days until the MOT. So I'll check this again tonight because I want to see the voltage when it's not had load for quite a period. So that's my real baseline. So this is just kind of a bit of an indication, but the real start point will be tonight. Then 5 days time, has it dropped at all? Hopefully it's okay, we'll get an MOT anyway. And then we will do some, well, we've got a choice after that MOT. We can either take the opportunity to do like a range test to really drain it and then charge it again. Maybe we'll do all that all within the day. Or after the MOT, just park it up again and leave it. I'm not sure. It's one of those two. It needs to be left for another period after that day. So, yeah. Not sure. It's possible that one was still reducing a little bit having been charged. Don't know. The proof of the pudding will literally be in the eating. What happens over the next few weeks with that cell? Is it any good? Next couple of months, we shall see. So yeah, it's out the workshop. Got to get a Zoe in next. Got to do a DC-DC converter, but I'll leave this and see what happens. Right, catch you later. Okay, so it is dark and it is raining, and it's actually slightly later than intended. So instead of being the evening of the day where I moved it, it's actually the next day, the next evening. So this is sort of a day and a half since I parked it up. And I was just looking back at the previous video, which you'll have just finished, and that was at like 893, and these were sort of 904, weren't they? And it's kind of maybe gone down a tiny bit. 90, but it's going up to 892, 88, I mean 83890, but it's not dropped a lot. So it's certainly had, so it may have dropped a tiny bit from, or you know, settled a little bit, because we obviously checked it just previously where we've just driven it, charged it and then driven it. And whereas, yeah, I really should have checked it last night. It's been a bit longer, but if it's gone down just with draining itself, it's a tiny amount, isn't it? 9.3, and it's now at, what's that, an average of 90, 91? I mean, we're talking 2-3 millivolts. Maybe that's the amount it's losing, and they just don't balance it enough. But yeah, the others are still about the same, aren't they? I mean, they would. I think they've settled a little bit as well. But yeah, so I will keep an eye on this. So yeah, it's Friday now. We'll leave it till Tuesday during the day. I'll check it before we sort of before we drive it, and we will see where it goes. So see what happens. Then after the MOT, yeah, we're still going to continue to monitor it. I don't know whether to do a kind of load test at that point. Maybe after the MOT, I'll take it for a drive just to make sure it's okay under load, and then charge it and then drain it with the heater, something like that, just so it's had a bit of a full charge and a kind of a cycle, and then leave it for like another week and just double check where we are, and then potentially, if it's okay, customer can have it back and sort of see how it goes over a couple of months. But yeah, so we'll continue to monitor that and we'll see where we get to. All right, cheers. Okay, so it is MOT day, so I haven't moved this van yet. I've still got the battery isolator out, so it can't use any power, and we're just going to have a look at that battery. So we have lost a little bit, haven't we, there? Looking at number 80, so what's that, up to about 30 millivolts? So it is draining. Is it too much? I kind of was expecting it to, because obviously in the previous
Yeah, previous one a few days ago, it had gone down a little bit. It's not massive, is it? But it is going down. So what I'm going to do is, so the van needs an MOT, that's absolutely fine to do it like that. What I'm then going to do is do a road test, and I just want to know that it performs okay, because obviously if after a few miles the voltage just starts to crash and the you know, like the performance, the range just goes away, we know it's game over anyway, waste of time. It needs a new battery. We obviously did a test just sort of down my lane and it looked okay, but that's obviously just momentary. So can it sustain output at high load? So we'll test that. Then after that, we'll give it a full charge. So once it's had the MOT, I've got to put all the like dash and stuff back together where I fixed the heater. I'm going to do that in a minute. Obviously put the battery isolator back in. So we kind of know that something is happening with that cell, whether it's the BMS draining it or not. Maybe it's got the balancer stuck on, seems unlikely. Probably is the cell, just going down a tiny bit. Yeah, so yeah, high load test, if that's okay, put it on a slow charge, so put it on the granny lead and leave it, and just see what it can do. Can it balance that out? It couldn't balance it out before, but it was about 45, 50 amp hours out, so not a massive surprise. But with a regular charge, with the way it is at the moment, would it be usable by the charity, just kind of at least for the kind of medium term? Would it keep working for now and they can do what they want with it and just got to fully charge it a lot just to balance it out? I don't know. I did joke with someone that I should put a couple of leads on that cell, stick a connector on the side of the battery, and then you plug in your connector and you plug in a little charger for that cell. But yeah, not ideal. No, if it can't balance it out, that's really the kind of telltale. I'm still genuinely surprised about these other voltages, that they don't vary more, because I saw more variance on the yeah, on my multimeter as you sort of testing down those. But yeah, it's interesting. Yeah, it's interesting. The BMS is obviously remote, and it's doing a kind of diff between the cells, so it doesn't obviously have 2 leads for each cell. If you've got 3 cells in a line, 2 cells in a line, so 2 in series, the middles is connected together, so you only need 3 wires, because you need the start and the end, and then the one in the middle, and you use the middle one to measure the first one, and then use that middle one again to measure the second one. So yeah, it kind of it does a sort of voltage diff, but it should measure it accurately, as my meter should as well. So that is kind of interesting. All right, it is going down. Okay, that is what it is. I sort of half expected that, because it's got to be going somewhere. Right, let's get it back together, see what the high load test is like, see what happens on a full charge, and then, well, see if we've wasted our time, I suppose. All right, it's all good. Okay, so the van got its MOT, which is cool. Makes things a bit easier, and I've taken it for a drive, and it performed absolutely fine. Basically, yeah, it was all absolutely normal. Yeah, good sort of performance, no faults, anything like that. So then when I got back, left the heater on for a bit, and I thought we'd then have a look. See, now we've got a difference of, what's that, 25 millivolts, give or take. So that's about 10 and, or if that's 10 and 43, now we're more like, no, 33, haven't we? Yeah, 33 millivolts. So yeah, it is opening up a little bit, isn't it? It is kind of opening up, because earlier we were at what, 20, and now we're at sort of 33. It's just sort of kind of beginning to open up. I think it is just kind of constantly draining all the time. I'm still fascinated, but that these voltages are all basically the same, whereas when I read them, they're kind of not. Let's have a look at, so it thinks we've got a 5% charge difference there. That's the bit obviously previously we tried to get to be better. I love it, the fact it says 97%. Yeah, and it's obviously not. Yeah, I've considered whether this van could potentially have a BMS fault. So maybe it had the bleed resistor turned on solidly, and that kind of would give this, but
it just seems like such a rare, such a rare occurrence. And the fact it's had one module replaced already, presumably this happened before, but then the other cell was worse. It just, it doesn't make a lot of sense, does it? Other than if the fact is that they don't like not being used. That's the only thing. So yeah, I'm a little bit disappointed. It has opened up more than I kind of hoped, albeit it was a massive difference before, wasn't it? So our real last hope is that the van attempts to balance it out when I charge it. So I'm going to put it on the 3-pin lead overnight. I've drained it down a bit, so yeah, it's at about 2/3, something like that. Is that a bit under 2/3? Yeah, a bit under 2/3. Yeah, so we'll see what happens, but yeah, kind of unless something staggering happens, this van's going to need a battery, isn't it? Really. Because that's just kind of a bit much. It's just such a shame because it performs so well, and the internal resistance test says it's healthy, but yeah, it is draining, or something is draining it. What will be really interesting is, I mean, whatever happens, whether we have to put a battery in this van, whatever, we'll get it fixed. Or if I could find a module. If there was a module on eBay, I would have put it in already. That's the silly thing. But I can't find any individual modules. I should get a price from Renault, really. I didn't do that. I just presumed it would be high, but I'll ask anyway. If there was a module available, I'd have put one in. But if I have to get a whole battery for the customer, then I'm going to have 11 good modules sat there. So, yeah, it's just a bit silly, isn't it? Because I only need one cell, really, but they're welded into modules. So therefore I need a module, but it's second hand anyway. Can't seem to find a module. There we are. Yeah, I quite enjoyed charging it up, though. It was good. It's been fun. It just might have been a waste of time. Yeah, okay. Well, I'll update the customer and see what happens tonight, basically. But yeah, it's so bizarre because I've been driving around in it. But yeah, it's got a fault. So yeah, the really odd thing, the odd thing is it didn't drain more for the amount of time it's been sat there. But is it just got a tiny little internal drain? I don't know. Yeah, what I was going to say a minute ago with with once it gets fixed is I will monitor the voltage of this module, and we will then be able to prove whether it is an issue with the cell or an issue with like the BMS, because we could have a BMS fault that's got the bleed circuit stuck on, but to prove that you need the cell not connected to the BMS, so therefore you just need it sat on the shelf for a week or two and see if the voltage goes down, and does it just go down over time, down and down and down and down, and that proves that cell is definitely faulty. Just seems so bizarre that this van's had to have a traction battery replacement before. But yeah, maybe this is what happens when the batteries are just not exercised, not used. Do they just really dislike lack of use? I know batteries don't want to be stressed too much, they don't want to be left full, they don't want to be left flat. Maybe they don't want to be just left doing nothing. Yeah, interesting. So we'll see what happens tonight. It's also slightly fascinating that I was reading the voltage as higher than some in my pack, but when I put it in, it reads lower. But it's not misreading. Yeah, it's just, strange, isn't it? Really, really odd. Okay. Well, we will see what happens in the morning. So yeah, I think it's low enough that it'll have a decent charge. I'll plug it in tonight, and then we'll see where we're up to. Have we got lowest and highest voltage on here? I don't think we have. There's not a lot at the top, is there? There's a lot of stuff at the bottom. Apologies if whizzing that along just made you feel sick. So everything's got 5% difference. Current is 0. it's just done. This battery's done nothing, basically. Yeah. I mean, I did have an option to get hold of a battery that had done 67,000. But it just seems so ridiculous, isn't it? To take one out that's done 9,200 and put one in that's on 67,000. But the 67,000 one is in a better state than the 9,000 one. It's stupid, isn't it? I mean, is it this chemistry? Because all lithium batteries are a little bit different, you know, your NMCs and your whatever. Yeah, interesting. Is it that this one in particular doesn't like being left doing nothing? Don't know. Okay, interesting. Right, well, we'll see what the state is in the morning, and then we'll decide where to go from there. I'm a little bit disappointed, but yeah, okay. We are where we are, and forwards we will go. Right, catch you later. Okay. Well, I think we've got our answer. The van is fully charged. The question was, could it balance it out? Would it balance it out? And the answer, realistically, is no. So 408, it bounces around a bit, which is really annoying, but I'm going to call that 485 to make the maths easy, and we're at about 4120. So we're at about 35 millivolts. So that's about what it was, isn't it? It's not particularly improved. It seems because of the health of the cell, it seems so likely that the balancer is stuck on and draining that cell, all apart from the fact that this battery has had a previous repair. So what happened last time, knowing that these batteries are quite reliable, did we have a balancer that failed before, but then they put a module on it? So they've had a cell failure before and a balancer failure now? Or it's just that this is such an edge case of usage that this van is literally hardly used, and they just don't like being not used. I don't know whether they've had it from new or not. Maybe this van sat around for a long time, especially over COVID. Maybe it literally sat there for 2 years and didn't move, and then that, you know, maybe that's what's really made some of the cells unhappy. It's hard to know. It's hard to know because, you know, let's say that last time it had a module because one cell failed. We've had 2 cells fail out of, what is it, 96 in these? Yeah. So, yeah, it's just so odd, isn't it? The way these batteries are constructed, so they're 8S2P. So what that means is you've got your 8, and we showed that on the module, but actually inside there's actually 2 pouch cells, so there's 2 in parallel. So whether something's happened with one of those cells, and that's why it looks like it's got good health, but something's going on, but it's such a slight difference. The ultimate test for this will be to sit this module on the shelf and see if it drains while it's not connected to anything else, and that's the real sort of telltale. What I need to do with this right now is just drain it down a bit, because I don't really need to go anywhere. And what I might do actually is just drive it a little bit, because I might as well use it. Might as well use the miles rather than put the heater on. But yeah, just to drain this down, because it needs some work. But yeah, is it the balancer? I think it's going to be the cell, and that it's just their edge case of usage. So the pressing question is what we're going to do next. So obviously you need to go back to the customer and say, look, you know, it's still dropping. It's not looking too good. We need to do something else. So Renault can supply a module. The downside is it's 2,000 plus VAT, which is a little bit cost prohibitive, because you know, on sort of you know, your favourite auction site, you can get a Kangoo battery of between about £1,000 and £2,000 basically. So we could stick a battery in it, and that would still be reasonable. It was worth trying to charge it up. It was good fun as well. I enjoyed it. But yes, ultimately, has not really worked. I would only give this back to them if that had balanced out, you know, during the overnight charge. If they could keep it balanced, excuse me, then that would be okay. But I can't give this back to them. It's going to drain in a few months. It's just going to come back. There's no point. But what I really need is a module. I don't really need a whole battery, do I? I just need one module.
but unfortunately no one split a battery and no one sells modules. The good news is that over there, which I will show you, over there, just yeah, past that fridge, is a Kangoo. Now that Kangoo is owned by a courier company. It's kind of half a Kangoo. Basically, there's a courier company in London. I've fixed 3 of their Kangoos. They've got a whole fleet of electric Kangoos, and basically they found me when they had like 3 of them broken and one they'd split for spares to fix a load of other vans. And they started bringing me these vans one after another. They would bring one, I would fix it. First one was reduction gearbox failure, so I did that. And they literally, the trailer would bring the second one and take the first one away. It was kind of depressing because normally you fix something and then you end up with less vehicles on site, but you fix it and you've got the same number. And obviously I'm booking in other customers, so it got a bit silly, but yeah, it's all good. So the second one was motor failure. Not motor failure, motor bearing failure. And they said, oh, it's going to cost too much. We'll bring you the next one and see what that's like. Next one was just a drive shaft. So we stole the drive shaft off the one that had the motor bearing failure. So that was all good. Sent that back. And then they said, right, the fourth one we've got, they said, is the one we've robbed a load of spares off, loads of bits. So they'd stolen like the airbag, they'd stolen, I can't remember, loads of bits and bobs, wing mirror, loads of stuff. And they said, if we bring you that one, can you see if you can make a good one out of 2? And I was like, yeah, okay. So the one that had motor bearing failure had a replacement reduction box fitted a couple of years previous. They do. These couriers do drive them like, they drive them like hire cars, if you know what I mean. They're the fastest vehicle on the road. But yeah, so the one with the motor bearing that was kind of number 3 had the new reduction box but bad bearings. Number 4 that they brought, they split it because it had reduction box failure. So I was like, okay, well this can work because I've got, you know, I've got the motor from the spares one and then I've got the box from the motor bearing one, number 3. So I've got number 4 in the workshop, stripped down number 3, took the reduction box off it, got number 4 in the workshop, took the box off. They'd kind of half stripped the front end down as well. I don't know what they were trying to get off it, but I think whether they were planning to fix it and they didn't. Anyway, then they split it. When I took the reduction box off number 4, I spun the motor and it had bearing failure as well. And they were like, no way. But they said, well, you know, we've got to get one of them back on the road. So just, you know, crack on sort of thing. So, yeah, basically I then took the motor out as well, did the motor bearings, put the reduction box off number 3. And to be fair, the bill wasn't that bad because it's like, you know, it was pretty much all labour because they were supplying all the parts basically, other than the bearings and stuff. So it was just a whole lot of labour and they got a van back on the road. But that van that sat there is the motor bearing failure, van 3, but it's got no drive shaft, no reduction box, it's got motor bearing failure, and it's just sat there because that's, you know, where I took the parts off it. And I keep meaning to put the wheels back on and then push it out of the way, just in case courier company need an onboard charger or whatever, they can send it here and I can sort it out. So the sum total of that means that there's a battery over there, sort of 20 yards away. Now that van has done 67,000 miles, which is ironic because this one has only done 9,000 miles. But the good thing is I can test that battery, look at the voltages, and that van was moving up until it had bearing failure, motor bearing failure. So I've got a battery for one of these on site. It wasn't the option I kind of wanted to go with because of the mileage, but the fact it's on site means there's no transport cost. I'll have a chat with the courier company and see if they'd be up for selling that battery. You know, this van hardly goes anywhere. I'm looking at the range, saying 103 miles. It doesn't really matter if the range is not as good because the value of that battery isn't going to be great. They'll just get some money. And I was thinking, well, I didn't really want to do that originally because the courier company, if they have a battery issue, they might want that battery. But if I've got a load of modules, that's not an issue, is it? So if I split the battery out of this van, obviously I can, you know, watch the voltage of this low one, cell 80, just for morbid curiosity to see what happens, see if it really is cell failure or slow, tiny self-discharge, whatever. But yeah, I can put that in the charity one of this van, the low mileage van, if the courier company have a cell failure or a battery issue, I've got a load of modules. They're very low mileage, albeit a couple of them have died, but the good ones should be good. I will put them at storage voltage, so I'll get them down to, it's about 3.6, 3.7 I think for this chemistry, I'll double check. But yeah, you can't leave it sitting at sort of 4.1, which is fully charged or flat. You put them at storage voltage. The next thing you've got to do is once they've settled, so storage voltage, which actually I can do, I don't have to do manually, I can do it with this van, can't I, by driving it around and putting the heater on. So they'll be at storage voltage. By the time I take them out, it'll be a while since they were drained. So the kind of settling period of the voltage to settle would have passed. You then get a Sharpie and you write on the side of the module what the voltages are. You leave it for a minimum of a couple of weeks and then you check them with the multimeter. Likely that they'll all be fine, probably other than that one, and then we'll know we've got a load of good modules. So if the courier company have a battery issue, there's a module for them. If this van has a battery issue in future, I've got modules. Yeah, so I've got a load of spares for everyone basically. So I think that is going to work. So yeah, I will probably talk to the courier company first, actually, just so that I can go back to charity and say, look, this has happened, but here's an option, kind of thing. I could get a battery on eBay. The thing is, I prefer a battery you kind of know. I can do tests on these batteries. I hate getting a battery and then you put it in and then it's got a cell gone or something, and that's why the van was split in the first place, just a massive pain in the backside. Whereas I know that battery, okay, it's higher mileage, but this van is hardly going to do anything. So as long as it works, it's good, it will be cheap, and I've got spares. So that is a pretty good solution. And the courier company will get a bit of money. So that could work. That could work. Right, well, I think that is it for this one. Realistically, it needs a battery. What's going to happen next is I'm going to put a battery in it and it's going to go back on the road. So I think we're going to call this video done. This is probably going to go down. I'll probably only come back to show you that this has gone down more. So I may do that in a minute. But if not, then I either didn't or I could be bothered. And now I probably will do. I'll have a look, because this van won't go very far. But we'll see what the offset is. I will drive it around a bit just so it's not sat fully charged. But yeah, if you made it this far, as they say, thank you very much for watching. Other than a minor update, that will do. And I will catch you later. So, yeah, just a final thought and a final look at this van. So it's been a few more days since the MOT and then the kind of like range test. And it has dropped a bit more. That's sort of like, yeah, more like 43-ish millivolts, isn't it? So, yeah, it is increasing that. It is increasing that slowly, but it is increasing. Having a chat with the customer saying, I can't really give this back to you. This is going to become an issue again kind of sooner rather than later, even though kind of things look good and it works well. That's not going to last. I got a price for a brand new module from Renault, which was 2,000 plus VAT, which is quite a lot. Interestingly, the customer's response was, well, that's cheaper than scrapping the van. So customer is obviously really keen to get this van going, which is really good. Obviously, we need to give them a reliable solution. So yeah, I'm looking into the options. I want to give them something that's good and is going to work for them. Whether it's that sort of pack I've got that's higher mileage, or yeah, different solution. But yeah, this van will definitely get back on the road. It's going to be a replacement pack unless I can find a module. I don't really want to put a brand new module in it because it's ridiculously expensive. I mean, I can get a good used pack for less than that and then have loads of spare modules. So although it's so annoying that you end up with loads of modules when I only need one right now. But yeah, that cell is obviously not well, is it? It is going down. So that's how it is. But this van will get back on the road. Yeah, customers are really keen, which is great. And thank you very much for watching. Cheers.